All right, Algebra 2, what's going on, guys? We are in Section 4 today, Chapter 5, Section 4. So we are going to do complete the square. All right, so what we've learned up to this point, we've dealt with graphing, we've dealt with factoring, and other forms of factoring as far as simplifying, but now we're going to do completing the square. So make sure you're paying real close attention here. All right, so this is another method that is very helpful, and we actually will be using this method a little bit later in a different chapter also. So it's just good to pick it up now and understand it. That way later on, hopefully you're not feeling like it's the first time all over again. All right, so if you could go with me in the textbook there, as it says, first thing you're going to look for is actually if you could solve a problem by using the square root property, which is way easier, but this is not going to work all the time. The problem has to be set up really nicely for the square root property to work. And if you could take a look at example 1 on page 341, and my first example problem is also going to correlate with that. In other words, it's going to make the square root property seem very simple, easy. Yes, it is, but there's a lot of problems, unfortunately, where the square root property isn't always going to work. So let's see if they don't work, what you have to do next. All right. One of the first steps in completing the square is finding a brand new value for c. Can you remember that the standard format for a quadratic is ax squared plus bx plus c? And that value of c is really important because a lot of times the way the problem is given, the value of c is not going to create what we're going to call a perfect square trinomial. That'll make a little more sense in a couple minutes here. But with this little equation you see on your screen there, c equals b divided by 2, that whole quantity squared, that will create a new c value that will make the trinomial a perfect square. All right, so keep listening, follow along. And there you go, page 343. That's a full breakdown of all the steps to do completing the square. All right, all 6 steps. I'd recommend it. Put that in your notes. And again, you guys probably hear the word recommend, and that means that you don't do it. But again, it's going to be helpful for the test, and you get that 1 page of notes. You might well use it wisely. All right, and then the last piece of notes here, the vertex form is a form that we have used in the past. We've also used it in this chapter, and you're going to have a style of problem where they want you to solve a quadratic that's in standard form by completing the square, but then putting it into vertex form. All right, so that's probably the very last example problem that we'll go through. All right, let's jump into it, guys. Here we go. So the first style that we have here, we're just going to use, as the first note said, the square root property. All right, so let's take a look at what this looks like if square roots work out perfectly. So the first step that I see is we're going to try to isolate that variable. All right, isolate x. So we're going to add 20. And that's going to give us a 4x squared equals 25. Then we could divide both sides by 4. That crosses that out. There we go. So now what you should see, that x squared equals 25 over 4. Here's where that square root property comes into play. Because 25 is a perfect root, 4 is also a perfect root. So what that allows us to do is we could take the square root of both sides, because how do you get rid of a square? All right, in other words, how do we get rid of this 2 right here? Is you have to take the opposite of it, which is the square root. So the square root will cross out, crossing out that 2, and now x is totally by itself. And because 25 and 4 are perfect roots, square root of 25 is 5, square root of 4 is 2. There we go. X works out quite nicely to be 5 over 2. All right, and the last piece is we're going to put plus or minus. That's something that you got to remember to do anytime you take the square root, because taking the square root works for both that positive and negative side. The reason why is because when you square a negative, it still becomes a positive. All right, let's take a look at example problem number 2 here, which, by the way, this is also going to work out perfectly. And this is your first exposure or first refresh of what a perfect square trinomial is. All right, this entire trinomial is actually a perfect square, okay? Meaning it will break down. I'm going to show you the double parentheses, but really it's going to break down into the same thing twice. All right, x squared breaks down into x. Notice plus plus is right there in the trinomial. So plus plus will be here. And then what are factors of 16? 4 and 4. What is 4 plus 4? It's 8. So it works out perfectly right there. But you'll notice that those parentheses are identical. So here's what I actually would like you to do. Write that parenthesis, x plus 4 squared, because you have 2 of them. All right, and then equals 49. Now again, how do you get rid of a square? The opposite is to take the square root. And you can take the square root of that whole thing because that entire set of parentheses is squared. So now what that's going to do, let's go up here. It's going to give us x plus 4 equals, and the square root of 49, 7. But you have to make sure that, again, you are representing both types of 7. So you're going to have x plus 4 equals 7. You're also going to have x plus 4 equals negative 7. Okay, because again, don't forget it's plus or minus. And that's going to give us a final answer where x equals negative 11 and a positive 3. All right, so you have to solve both of those equations, x plus 4 negative 7 and x plus 4 positive 7. All right, good. Let's keep moving. This is kind of like baby steps right here into completing the square. So let's find the value of c, because really that's going to be step 1. And they give us a and b, they don't give us c. And just a refresher right there, the equation to get c is do b divided by 2 and then square it. So you'll notice that means it's always going to be a plus c, because if you square it, you're always creating a positive. All right. Okay, here, so I would do 4 divided by 2 quantity squared. What is 4 divided by 2? It's 2. Square it, you get 4. All right, this one right here, 3 over 2 quantity squared. A little bit more space. 3 over 2 really doesn't go anywhere. So when you square it, you have to square the 3 and square the 2. So that's going to give you 9 over 4. All right, and that's good. Leave it like that. Don't make it a decimal. Always keep these as fractions. Okay, so that's how you would solve for c. Now let's go ahead and do a full problem where we have to complete the square. All right, so this right here, the reason why I picked this problem as an example problem is because there's something you actually can do before you ever attempt to solve for c. Okay, you'll notice that you have a 3, a 24, and a 27. All of these numbers are divisible by 3. So technically, your very first step is, can I factor anything out and simplify the problem from the way that it was given? In this case, yes, you can. So this whole thing, let's put it in parentheses and take a 3 out of all of these guys. So now we have a 3 parentheses x squared minus 8x. I'm going to leave a little space equals 9. Now, in that space, I need to solve for c. So go through the same steps. Remember, c equals b over 2, that whole quantity squared. So b is 8. 8 divided by 2 is 4. 4 squared is 16. So that's my brand new c value that I have right there. But here is now, from this point on, these are the new steps because I haven't shown you this yet for completing the square. If you put a brand new c value right there, what you do to one side, you always still have to do to the other. So that means I need to add 16 to the opposite side as well. So you have a new c value. That's great. Put it in the place where c belongs, but add c to the constant value on the other side. Okay, so now what we're looking at, let's go ahead and close that parenthesis, and let's factor that perfect square trinomial, because this right here is now a perfect square trinomial. So when we factor that, it's going to factor to x. There's going to be a minus sign and 4. And don't forget to square it. All right. So the way that I know this, if you remember back in that video where I was reviewing factoring with you guys, that was this chapter. You see how this sign right here is a plus sign. That means that I have to go back and look at the first sign because that's what both of the parentheses will be. Factors of 16 are 4 and 4. If I have a negative 4 and another negative 4, that will be a negative 8. But if I have a negative 4 times a negative 4, that would be my positive 16. So that's why that works just the way that it is. And then equals, and this side is going to make a 25. Now we like it. Now you should see 25 is great. That's a perfect root. We also know the other side is a perfect root. So let's go back and do the steps that you've already seen. Take the square root of both sides. And now you're looking at x minus 4 equals 5. And then another x minus 4 equals a negative 5. Because you can't forget, the square root is going to give you both the positive and the negative, giving us a final answer here where x equals negative 1 and 9. There you go. So that is a decent style of completing the square, all the steps right there. Okay, this is our last example problem, but now we're going to do vertex form. Okay, vertex form, by the way, is on page 344 using example problem 4 in the textbook. That might be a good help with this. Okay. So if you take a look, let's see what we are going to do for vertex form. The first thing we're going to do is we're actually going to separate a and b from the c value that they gave us. Okay, so you're going to have 5x squared minus 50x. Then we're going to leave a space plus c. Separate that, and then off to the side we have the old c value that we can't forget, but we're not going to use it here because we're looking to create a perfect square trinomial. All right, so let's go ahead and notice that 5 and 50, we could take a 5 out. Okay, and if we take a 5 out, let's do that. We have a 5 there. That creates now x squared minus 10x plus, and now let's create that brand new c value. How do we do that? Remember, c equals b divided by 2, that whole quantity squared. So 10 divided by 2 is 5. 5 squared is 25. All right, now what you're going to see is this plus 128 over here. All right, we now need to do something to that. there's actually two things that we need to do to that. All right, here's what we need to do. We factored a 5 out, but that 5 never disappeared. It's still there on the outside of the parentheses. And remember, we did not take it out of the 128. So we now need to represent that back. All right, so here's a minus sign. Let's see. All right, I'm going to do this in a different color to show this is something that you got to do to the negative 128, or sorry, the positive 128. Now we have minus, and in parentheses, I'm going to put both parts. You have 5. That 5 is coming from that 5 right there, times 25, and it's coming from that 25 right there. And that, just so you know, will actually equal 125. So 128 minus 125. So that 128, it may have been the biggest number, kind of stands out like a sore thumb. But if you take 125 away from it, it's going to work out nicely. Drop it down to a 3. So let's simplify everything that we're looking at here. Okay. Here's what we have. We still have that 5 on the outside. This is now a perfect square trinomial that is going to factor down to x minus 5, that quantity squared, plus all of this over here is going to create just 3. Okay, now what you're looking at is the vertex form. That's why all of this looks so different from completing the square, because we did not want this to be in standard form. All right, look at the directions right there. We want vertex form. So vertex form, it's totally different. Yes, that's why your answer here looks totally different. But because it's in vertex form, you can now look right at this and pull the vertex out. All right, and if you don't remember that, go back and review the old videos in this chapter where we did vertex and we pulled the vertex out. So how do we get the vertex? This value right here is your y value, 3. This value right here, remember where we talked about, I believe it was h, but it was a negative h. See how that says minus 5? That means what we're pulling out is a positive 5, because the vertex, that x value, was a negative h, and it is a negative, and double negatives make a positive. All right, so I'm going to need all of this right here, the vertex form, and I'm going to need all that right there, the actual vertex itself. Whew, there we go. That's the whole thing, guys. That covers all of the section on completing the square. All right, I'll see you in the next one.